Αγαπητοί μας φίλοι, καλωσορίσατε και σήμερα εδώ στο αμφιθέατρο του Ερίκος Δινάν καθώς και στο διαδίκτυο. Σήμερα κλείνουμε όλη αυτή την σειρά των μαθημάτων για τα medical statistics για να φτάσουμε εκεί που από την αρχή θέλαμε. Δηλαδή πώς πλέον μπορούμε να γράψουμε ένα paper αξιοποιώντας όλη αυτή τη δυνατότητά μας να αναλύσουμε το αρχείο μας και να βρούμε όλες τις παραμέτρους εκείνες που θα το κάνουν ισχυρό και δημοσιεύσιμο. Όπως ήδη γνωρίζετε, οι διαλέξεις αυτές θα αναρτηθούν και στο site της Εταιρείας Ελλήνων Χειρουργών Καρδιάς, Θώρακας και Αγγείων και μπορείτε συνολικά να τις δείτε εκεί και να βοηθηθείτε ανα πάσα στιγμή ώστε να αποτελεί αυτό το πράγμα μια διαχρονική βοήθεια για όλους μας. Να καλωσορίσουμε και πάλι τον φίλο καθηγητή Αντώνιο Καλαφιόρε, ο οποίος πραγματικά στέκεται δίπλα μας ακαδημαϊκά, συμβουλευτικά. Είναι ένας μεγάλος δάσκαλος και χαιρόμαστε που συνεργαζόμαστε μαζί του. Αντώνιο, welcome again and you are ready to start the last lecture about medical statistics. Thanks a lot.
Good afternoon, everybody. This is the last lesson that is included in the statistical course. Of course, because the purpose of statistics is not something as abstract, but you need to do something specifically for a purpose, and the purpose is to write a scientific paper. Here we will evaluate how to write, or this is the method to write a scientific paper. Of course, we will not talk anymore of statistics. That was the object of the previous talks. When you want to design a scientific study, the first thing you must ask a question. What do you wish to know that you already do not know? The rationale is why do you want to know this, and the purpose of your study. What do you expect to learn? First of all is the hypothesis. The hypothesis means that you must think to something that must be the object of your study. This comes from many things. This comes mainly from the literature. You read papers and you find something that you think can be interesting, or you have some relationship with your activity and you want to explore. Or it comes from your personal experience, your daily life as a surgeon, as a physician. And in this setting, you think that an aspect of your experience deserves to be evaluated in depth. But the purpose of everything is to have the idea. So to have something in your mind that can bring to necessity to further evaluation. And another aspect of the idea is the imagination. Why? Because logic, as you can read, will get you from A to B, but imagination will take you everywhere. There is a danger. The danger are that empirical observation can be the basis of a research, and this is normal, but they are not the research. And your perception of reality is not the reality, but remains a perception which needs to be investigated. So you must be very careful that what happened in the last week is not a review, but you need to validate anything you have in your day everything happens in your daily life. You must generate an hypothesis, as we said, but first of all, you must improve your knowledge. Many papers support my idea, so it means you are reading and evaluating what the literature said about something similar to what you think. Or you can find there are no information about the subject. This is the best way, means that you are thinking perhaps something that nobody was thinking before. None had demonstrated it, or there is a physiological base. These are all these aspects are supporting or rejecting the benefit that can come from your idea. So this information are a lot of points that are scattered everywhere. But with the knowledge you are starting to put together all these points, but as we said before, with imagination, you can find a design behind all this information you got. What are the steps you need to start when you are the steps you have to follow when you are starting a research? First of all, you must specify the question you are asking. Determine which variables are relevant to the question. Design an experiment that controls or randomizes the confounding variables. You know that the variables are the most important things you can find, and the controlling with different tools is the most important aspect of your research. Just to let you a stupid example, if you evaluate the survival of two groups of patients, a variable is the age of the patient. If you are comparing the survival of a group of patients 8 years or old, comparing with a patient that are 30 years or older, of course there will be a difference. So you are not controlling the variable age. This is just a stupid example, but is an extreme example. But this is the meaning of controlling the variables. Later on, when you have an hypothesis, you must design a study. The most diffuse studies that we are doing are observational and longitudinal. These longitudinal are, as you can see here, retrospective. So you are asking yourself what happened, and you are taking patient from a period of time, here is from the 2011 to 2015, and you are evaluating these patients. The study can be prospective, so you are starting now, you are looking at what happened with, say, a group of patients in the next 5 years, from 17 to 22, for instance. This study is a prospective study, and the question is, what will happen? And if you see here in like arrows, in the retrospective cohort study, the exposure to the fact that can be surgery, for instance, and the event that can be death or life, or the death or alive, already happened. So you must only check what happened. In the prospective cohort study, the exposure happened in the moment the patient is entering the study, but the event, that is the death, for instance, of the patient, or the fact that the patient remains alive, has not happened so far. In the observational longitudinal study, the analyzed variables are monitored but not manipulated. So you are just observing what happens. Two groups of subjects are involved. Every time you need a comparison group. The first group is exposed to a supposed risk factor, let us say the alcohol, whereas the other one is not exposed. The aim of the study is to follow up the two groups to verify the exposure, if the exposure may cause the event, like, for instance, esophageal cancer. Usually is prospective. The study starts when the event has not already occurred, and the cause-effect relationship is evaluated starting from the cause, determinant. The strength is that you establish time sequence for causality, but the weakness that is slow, expensive, and the exposure may change over time. So someone that is drinking currently alcohol can stop drinking alcohol, so is not anymore in the study. The other kind of studies that you have are the prospective randomized controlled trial. In these studies, the analyzed variables are monitored and manipulated, because you are just putting in the study patients that have specific factors that you are already established before. The subjects are included or excluded into the study according to selected criteria, and then randomly assigned to treatment or control. The study can be blind, subject or physician do not know they assigned the treatment, or double blind. Both subject and physician do not know they assigned treatment or placebo, for instance. This is very useful to verify the effectiveness of a treatment. The strength of the controlled randomized trial is the possibility to isolate the effect from the confounder factors, even when the latter ones are not known. The randomization provides the homogeneity of the two samples. Can be the gold standard for any kind of evaluation. But the weakness, first of all, are ethical concerns, especially in surgery. Can you expose the patient to something totally new if you don't know anything about what would be the future of this? Restrictive selection is another weak point. Why? Because extrapolation of the results to the entire population can be a problem. Small samples, because these small samples are another weak point, because they in general are not able to demonstrate the difference regarding low event rates. And finally, very high cost. So this means that randomized controlled trials are not as good as they appear. Look at this study that was published in 2006. They evaluated all the randomized controlled trials sponsored by for-profit and non-for-profit organizations. The high cost is the problem that they have. Being a high cost, someone must put money. And most of the time, the money is put by the companies. And these are the RCTs that were published during the years 2000 to 2005 on 3 major journals, JAMA, The Lancet, and New England Journal of Medicine, sponsored or not sponsored by companies. Look how many, the percentage of these trials in favor of the new treatment compared with the control. Of course, the new treatment is the base of the sponsorship. When the sponsor was a for-profit sponsor, like a company that is producing something, 82% of the trials were in favor of the new treatment. When there was not for-profit study, only 50%. So it means that there is a problem. Again, more recently, in 2015, 182 controlled trials, randomized controlled trials sponsored by industry were evaluated. They were published all in 2011. Overall, 83% were favoring the industry that sponsored. If you are evaluating a non-inferiority, that is a very bad way to do a study, close to 100% were favoring the industry. And in 92% of the cases, we had every time a conflict of interest, because most of the doctors that are publishing this paper are themselves sponsored and paid by, officially of course, but they are sponsored by the industry themselves. So this is a very bad way to organize things. So the alternative to randomized controlled study is the propensity score matching. Propensity score matching means the following. 2 groups of patients who received in the past treatment A, let us say LITA to saphenous vein graft, instead of treatment B, 2 mammaries, are made similar according to some risk factors. Groups are then made homogeneous after and not before the treatment. And just to let you know, between the year 1990 and 2014, look at the number of the propensity score studies that were published. It's a very important number of studies. To build a propensity score model, logistic regressions to be used to find the risk factors for treatment A. That is the treatment we want to evaluate. For instance, the use of 2 mammaries. All risk factors identified by a score, and the patient who received the treatment B, in this case, for instance, mammary plus 1 vein or anything you want, are selected in such a way to present a similar score. So it means that the groups are more or less similar. The variables to be included in the model can be only the ones who show a statistical significance, or all the variables regardless. These are the origin of these 2 terms, parsimonious model and non-parsimonious model. Personally, I prefer to put all the variables, and that is. The advantages of the propensity score studies is that this study is able to balance a large number of covariates without losing a large number of observations. If you have 2,000 patients, in general you are able to put together 75% of the patient. Disadvantages that only account for observed and observable covariates. Any hidden bias due to latent variables may remain after matching. And in general, you need large samples. But I want you just to show you what was the opinion of one of the most important medical statistician. Dr. Hannan published a lot of papers on PCI versus surgery. He's the statistician of the New York State, just for and is an authority in this field. Because of the cost of the randomized controlled trials, the amount of time it takes to conduct them, the difficulty recruiting subjects, that is objectively true, and the fact that because they generally expect only small to modest differences in outcomes, otherwise they would be identical, they are frequently underpowered to detect important differences in outcome. This can lead to erroneous conclusion, in generally false negatives, that there are no significant differences in treatments when a larger sample size would have uncovered significant differences. If you have a 2% difference and you are evaluating a few patients, of course there is no statistical difference. If you are evaluating thousands of patients, 2% will be a big difference. And the same Annan wrote, randomized controlled trials have a specific inclusion and exclusion criteria that are often quite restrictive, whereas observational studies usually apply to much broader population and are frequently even population-based. The randomized controlled trial population usually do not mirror the age, gender, and the race distribution of the target patient population. In general, they tend to be less sick, younger, better educated, and of higher socioeconomic status. This means that they are more adherent than the mean to the old protocol that is established for these trials. In the case of randomized trials that involve procedure-based intervention, informed consent can be more difficult to obtain than in the drug trial, for instance. What we know from our side, it has been estimated that as few as 2 to 5% of the patients screened were randomized in the early PTCA versus CABG trial. The problem is that extrapolation of the data from the small number of patients to the general population is surely not correct, because this is true for this kind of population, not for the 95% of the population that is not involved in these trials. Anyway, the second step, when you decide what you want to do, you have to collect the data. When you decide you must, with kind of research you want to do, first of all, you must write a protocol. And these are basically the first step. In a approximative study, a protocol is to be written before starting the study. Of course, you want to work for the next 2-3 years, and you might need to know what you want. On the contrary, in a retrospective study, the protocol can be written either before or after data collection. When you have a prospective study to do, in the protocol you must state rationale and hypothesis. You must indicate the subjects and the primary outcome. You must do a statistical power analysis to have an idea of how many patients you need to demonstrate your endpoint. Indicate measurements to be done and when. Determine methods of measurements. You must state how data will be collected and put in order. And now is the most important thing, you must state the statistical test you want to use to analyze your data. You must list the key references and define the closing interval. So when the study will finish, you must do a study, you must say, I want to explore, even the retrospective study, you must decide a cut point when you finish to evaluate your patients. Specify the method of follow-up. What method of follow-up will be used during the closing interval? Visit to the clinic, telephone, letter to the patient, to the doctor or to the doctor. Which information will be obtained at the end of the closing interval? Catheterization, MRI, CT angio, ECG, anything you want, but you must put there clinical information. You must decide what you want to know. When you write at the last follow-up, this is a meaningless term, and unfortunately is commonly used, but doesn't give any information, because you must say the end of the follow-up was June 2018 or June 2015 for a retrospective study. In the retrospective studies, you must define inclusion and exclusion criteria. Years spanning the study period, I want to evaluate from 2000 to 2010, but you must state what you want to do. Determine the outcomes of the study, and the primary outcome, that could be, for instance, a death or life, is the most important question, as power analysis is based on it. You can add the secondary outcomes. For instance, in a surgical population, you wanted to explore the ICU stay, the stroke incidence, acute MI, and so on. But remember, you needed to have a certain number of events that must be around 18 to 20 for each outcome to evaluate them using a multivariate analysis. Again, if you have 100 patients and you have 2% mortality, it will be very difficult to have with the 2 deaths a pattern of risk factors for this kind of operation. If you are evaluating 1,000 patients, 2% are 20. 20 are enough to have an idea of the risk factors of this patient. So it's not the percentage, but the amount of events that represent this percentage. Design the study for analysis by logistic regression statistics, because you need the propensity matching. If you cannot do any study, if you have not a comparison, otherwise you can just state, I did this, these are the results. But most of the time, this way of doing studies is totally meaningless. Choose the method of follow-up and the closing interval. Before starting your study or data collection, you need 2 more steps. The first one, you must obtain the approval of the ethical committee of the institutional review board of your institution. This is very important because nowadays you cannot do anything without informed consent, sometimes insurance for the patient. Anytime you have a patient must do a choice, so you must choose something, you must have an informed consent, and most of the time you need insurance and the ethical committee approval. Not most of the time, all the times. So you cannot move now in this field without asking the permission to a lot of people. And it's easier to have permission for retrospective study because you are not interfering with anything. Of course, you must guarantee the anonymity of the patients, so the patient cannot be recognized, but this is not an issue. The issue that when you are observing the patient, for the prospective study, you must have the permission of the patient to observe him. In the retrospective study, no. If you have a choice, it's a big mess. You must have even insurance, as I told you, because it's very important. If the patient has a damage for this, who will pay sometimes for the rest of the life? Second, you have to decide in which journal you want to send your paper to. Read the information for authors. This is very important. And look the guidelines for reviewers and authors. This is very important because most of the journals are more or less the same, but some journals have a different principle to be followed. Later on, the analysis. Based on the number of variables, the kind of variables, the expected fit to the parametric assumption and the hypothesis to be tested, you must choose the best statistical test to be used. Already we will not talk about this because we spoke for 5 lessons before. But you must evaluate your data. You must, before choosing statistical test, as perhaps you remember, you must decide or evaluate if the distribution is normal or is not normal for the continuous variables that are most of the variables, as most of the variables are continuous. You must choose the most appropriate test. Apply the statistical test you chose and interpret the results. Communicate your results effectively. Prepare tables and figures first. The first step, you have your database, you must analyze, just put the tables. So we have a number of patients, age of patient, gender, you must put all in order and evaluate what you have in your hands. You must write legends for tables and figures in separate sheet of paper. Write the text last and do not discuss the data in the results because this is not for the results. For instance, this is a very busy table, but you have a lot of information here. So within one table, you give a lot of information. Of course, this is not applicable for non-numerical results, but this is the best way to represent a table like this, the best way to represent your data. Choose the figures carefully, only to emphasize very important results. Most of the journals do not allow you to have more than, for instance, 6 tables or figures. So you must choose one figure or one table. We must say that most of the journals allow supplementary material to be put online, but not printed. Kaplan-Meier curves are best shown as figures with the patients at risk, and these are the most important. If you are presenting a correlation graphs, X versus Y, should provide the numbers of the regression, the legend, and so on. Bar graphs do not provide information. Please try to avoid the bar graphs. They are totally useless. What is represented in a bar graph can be represented in one line in a table. So these are in general used to emphasize something, but choose carefully the bar graphs you want to use. Finally, you have the comments. Think about your data in relation to your hypothesis and the primary outcome. What did you learn from your study that you did not already know? Outline your thoughts first and put them in logical order. Then write the discussion. The discussion must be done at the end. When you have material methods, the most important things to write are material methods and the results. Because when you will write both, you have the paper is in your hands. So the discussion is consequent to what you have. Do not repeat your results in the discussion. This is something that is not, nobody is glad. The length of the paper is very important. Sometimes you are allowed to have 3,000 words. Sometimes circulation allows you to any word. You can write a book if you want. But as others, you are allowed 2,000, 2,500, 3,000, and so on. So you must carefully select the words you want to write. Do not write a lot of things, because at the end they will count. Of course, the computer will count the words. Explain why your data are important. Integrate your data with that of other published studies. Finish a full draft of the paper. Then at the end, write the abstract. When you wrote everything, write the reference list. But you must finish everything. Otherwise, there are programs for the references that are very useful. So you don't need to rewrite. But sometimes you have not this program. So every time you are changing a sentence, you must rewrite some of the references, or changing the numbers of the references every time. So it's a little bit complex. So the reference list must be written just at the real end. List references in numerical order of appearance in the text, beginning with the first reference in introduction and methods. Add acknowledgements if applicable. Review again information for the authors to be sure that you have complied with all the journal's requirements. And the most important, have a look to the language. Remember the following: 17 of all people in the world speak English. 5% are native speakers. English has 1 million words. Most of them are technical. Basic English is simple. Complex English is not. After you finish a final draft in English, obtain help from a native English speaker who also speaks your native language fluently. This is very important, because most of the journal will ask you to control the English, because some are doing it themselves. So, but some other send you back, so please check the English, later on give us back your paper. But this is another point. You must carefully review the paper when you have back the paper from the reviewer, for English reviewer, because sometimes what you want to mean is not the same that is present after a good English translation, because the professional translators are not doctors, so they do not perhaps understand something that can be very important. This is what anytime my English is not bad in writing. Nevertheless, every time I write a paper, I send it to someone that I know that is doing this for as a job. And the paper I received back is fantastic. I said, if you see, exactly the same thing, but it's written in a totally different way that I can write. So I think this is the best presentation for a new paper, is to have a new paper in a good English. If your target is to publish it in an English paper. Finally, send it in. But now, what is this? This is what happens. You have your paper in your hands. You send your paper. Before paper is accepted, this is, says the famous song, is a stairway to heaven. You have a lot of people in the middle, A lot of people will ask you a lot of questions. Sometimes the questions are very stupid. Don't think that all the reviewers are very intelligent people. Some of them are reading the paper in 5 minutes. Some of them do not read well the paper. Some of them do not understand the paper. Sometimes your paper is rejected because of reasons that are not in the paper, and you cannot do anything because the editor will not hear to you. Only once it happened to me that a paper was rejected. I wrote a long letter to the editor. He asked for a re-review and was accepted because sometimes they are irritating. But this is the way things are doing. So sometimes a good paper took months before being published because are rejected by many journals. At the end is accepted, sometimes even not accepted. You don't know what it is. But anyway, you must be brave and you must be quiet because this is the way things are going on. Thank you so much for your attention.
Okay.